the square root of 72. And this is, Jenny, why I asked you about your... Oh, look at Jenny, already checking her square root table. Was that one of our perfect squares?
No.
No. If you don't see it on this column over here, you're out of luck, sort of. But here's what you're going to be doing. I'm going to skip ahead a little bit. I can choose to rewrite that as the square root of 2 times 36, correct?
So will we just divide by 2?
Yeah, and actually, I'm sorry, you know what? I'm going to write it differently. I'm going to write that as the square root of 36 times 2. I can also write it as the square root of 9 times 8, the square root of 6 times something, 12. You write all those sorts of ways. But
6
I'm thinking...
times 12?
Yeah, 72.
Oh, wow.
But I'm picking 36 times 2 because 36 is a square root. And now, according to this rule, I can split it up again into the square root of 36 times the square root of 2. Okay? And now, what is the square root of 36?
6.
6. So I can make that 6 square root of 2. And this is actually the simplest form of the square root of 72. This is how you simplify a radical. Okay? You take advantage of this rule here, that you can split it up. We'll do a couple more of those.
Can we do it real quick? Like another one?
Another one.
J-ball. Oh, that's supposed to be.
You suck.
Let me stop. Do another one real quick. All right. Wait for it.
Mr. Belvo,
Yes?
is this in Zoom?
Not well.
It's
But
hard
it's high def, so you'll be able to see it.
Because it is like hard to see.
On that little screen, yes, but the actual recording will be high enough definition that you'll be able to see it fine.
Oh.
Okay, now, let me come up with another example. Here's another one.
Huh? Not your face.
Okay, square root of 147. Square root of 147.
I need a calculator.
Wait.
No, it's actually not. Looks like one, doesn't it?
13
It's divisible by
It's either 12 times
8
12.
probably now.
No, that's 144.
12.
13 times.
12.1 and a half.
No, my God, stop. You can't. Don't try to guess decimals with these. They don't work that way for reasons we may get into later. See, I happen to know that this is 49 times 3.
Mr. Belvo.
This is 49 times 3. Now, I can split this up now in the square root of 49 times the square root of 3. And what is the square root of 49?
7.
7. So the simplest form of this is 7 square root of 3.
It's funny how the simplest form can be written as a longer thing than the non-simple form.
That is actually interesting, yeah. Now, guys, because the square root of 3 is a prime number, can't be factored any further, and the square root of 2 is also 1, this is as far as you can go. Because these aren't perfect squares.
What if you have a number that can keep going?
Well, hold on that thought. Let me get to one more rule, and then we'll do some examples of that. Okay? Now, next rule is, if I have the square root of A divided by B, I can make that into the square root of A divided by the square root of B.
Can you use actual numbers?
I will do an example right now. I would like to give the general first. So if I have the square root of 9 over 16,
Bless you.
okay? Bless you. I can take the square root of 9 and the square root of 16 separately. Are they on our list, 9 and 16?
Would it be 3 and
3 over
4?
4.
Yes, so this would be 3/4.
What about the sign?
When you get to Algebra 2, we may ask you to do it plus or minus. But for Algebra 1, we're only asking for the positive ones when there's a positive. And if I want the negative, I'll put the negative in front.
No, I mean, what about the, check?
The radical? That goes away when you perform the operation. Okay, once you've done what it's asked you to do, it's gone. You don't write it anymore.
Except for that.
Well, here, that's because, see, check it out. We found the square root of 49, but we did not find the square root of 3. It's about 1.7, but we're not looking for about. And so we're going to keep writing it like this. That's a great point. It did go away from this part. It didn't go away from this. Okay? I'm going to talk a little bit more about this now. This rule is fairly straightforward. All right, so, Nick, you want to follow me back over here? I'm going to leave these columns up.
He is the worst counterman.
Shut up.
Stop.
I'm gonna hurt you.
Okay, now, I don't want to do numbers. Okay, first thing, I'm going to go back 2 steps now. Have you guys ever learned your how you know if one number is divisible by another number without a calculator? Divisibility rules?
Like the 2, 4,
I
7.
got it.
Like 7 doesn't have a rule, but 6.
Yeah, you got it. Okay. I'm going to go back and go over these a little bit, because these could help.
You can't get a whole number when you divide it into an odd.
No, like a
No,
number
it's not
is
like
divisible by
that.
2 if it's an even number at the end. And for 3, it's if the last number is divisible by 3.
Hold that thought. No, you're mixing and matching, so hold on. Let me get this. Let me make sure I get this straight for them. Okay. Divisibility rules. Okay? If you're looking at a number and you're wondering, bummer. If you're wondering, okay,
Can you put the dots over your eyes?
it'll make you feel better.
Does that bother you,
Okay.
You
Jordan?
forgot 2 other eyes.
3.
All right, okay. A number is divisible by over here. And I'm going to put if over here. And these rules can be confusing, but I'll wait till the end. Well, I'll try and get an example in
A
over
number
here.
what?
A number is divisible by, and then I put a colon, if, and over here is an example. Okay?
I remember for 3, it's if they add up to something divisible by 3.
That's right. A number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. In other words, if it's an even number. Number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. For example, 524. I don't know much about it, but 4 is the last digit, so I know it's even. I know I can divide it by 2. Okay? That's my first rule. A number is divisible by 3 if, write this carefully here, the sum of all the digits is divisible by 3.
147.
Yes, we just did that. 147. Adina's first guess was it was prime, but then she said, what's 1 plus 4?
We learned
5.
these rules last year.
Great, why didn't you remember them? Never mind. Okay, we're going over them again. 1 plus 4 is 5, plus 7 is 12. 12 is divisible by 3, so 147 is divisible by 3.
You're a genius.
Okay, so that means if I have a prime root, if I'm looking at the square root of 147 and you're wondering if it's prime, no, it's divisible by 3, it's not prime. And then if I divide it by 3, I find out it's 3 times 49, and then I know 49 is a square root. That's how we're gonna use these rules. Okay?
Yeah, my
I'm
least
gonna
favorite
ask you
one.
if
It's 8.
8 sucks. So I'm going to ask you, is this number prime? And if you say yes or no, I'm going to ask you to justify it with these rules. Okay? Now here's one. A number is divisible by 4. This is different. Pay attention here. If the last 2 digits form a number divisible by 4. The way this rule works is 100 is divisible by 4. Any multiple of 100 is divisible by 4. So all you have to look at is the last 2 digits. And that will tell you if the whole number is divisible by 4. So I can give you a number like 1,227,003. Can't give you that one. 316. And all I do, Jordan, is look at the 16. Is 16 divisible by 4? Yes. So the whole number is divisible by 4. I don't know what's going to happen when I divide that by 4. I don't know how big or ugly that number is going to be, but I know it is divisible by 4. I know it's not prime at least. Does that make sense?
Sure.
Okay.
Can we take a break? My head hurts.
Now, rule for 5 is the last digit, guys,
Big shot.
is
Sorry.
0 or 5. You guys know that one, right?
Yeah.
If I say is 25 divisible by 5, you say
No.
yes.
Yes.
If I say is 150 divisible by 5, you say
No.